Caliche is a sedimentary rock, a hardened natural cement of calcium carbonate that binds other materials, such as gravel, sand, clay, and silt. It occurs worldwide, in aridisol and mollisol soil orders, generally in arid or semi-arid regions, including in central and western Australia, in the Kalahari Desert, in the high plains of the western USA, in the Sonoran Desert, and in Eastern Saudi Arabia Al-Hasa.Caliche is also known as hardpan, calcrete, kankar, or duricrust. The term caliche is Spanish and is originally from the Latin calx, meaning lime. Caliche is generally light-colored, but can range from white to light pink to reddish-brown, depending on the impurities present. It generally occurs on or near the surface, but can be found in deeper subsoil deposits as well. Layers vary from a few inches to feet thick, and multiple layers can exist in a single location. In northern Chile and Peru, caliche also refers to mineral deposits that include nitrate salts. Caliche can also refer to various clay-like deposits in Mexico and Colombia. In addition, it has been used to describe some forms of quartzite, bauxite, kaolinite, laterite, chalcedony, opal, and soda niter. A similar material, composed of calcium sulfate rather than calcium carbonate, is called crust formation. Caliche generally forms when minerals leach from the upper layer of the soil and accumulate in the next layer, at depths of approximately 3 to 10 feet under the surface. It generally consists of carbonates in semi-arid regions. In arid regions, less soluble minerals form caliche layers after all the carbonates have been leached from the soil. The deposited calcium carbonate accumulates, first forming grains, then small clumps, then a discernible layer, and finally, a thicker, solid bed. As the caliche layer forms, the layer gradually becomes deeper, and eventually moves into the parent material, which lies under the upper soil horizons. However, caliche also forms in other ways. It can form when water rises through capillary action. In an arid region, rainwater sinks into the ground very quickly. Later, as the surface dries out, the water below the surface rises, carrying up dissolved minerals from lower layers. This water movement forms a caliche that tends to grow thinner and branch out as it nears the surface. Plants can contribute to the formation of caliche as well. Plant roots take up water through transpiration, and leave behind the dissolved calcium carbonate, which precipitates to form caliche. It can also form on outcrops of porous rocks or in rockfishes where water is trapped and evaporates. In general, caliche deposition is a slow process, but if enough moisture is present in an otherwise arid site, it can accumulate fast enough to block a drain pipe. Examples of natural occurrence. While the formation of other caliches is relatively well understood, the origin of Chilean caliche is not clearly known. One possibility is that the deposits were formed when a prehistoric inland sea evaporated. Another theory is that it was deposited due to weathering of the Andes. One of the world's largest deposits of calcrete is in the Makgadikgadi Pans in Botswana, where surface calcretes occur at the location of a now desiccated prehistoric lake. Economic uses. Building applications. Caliche is used in construction worldwide. Its reserves in the Llano Estacado in Texas can be used in the manufacture of Portland cement. The caliche meets the chemical composition requirements and has been used as a principal raw material in Portland cement production in at least one Texas plant, where the calcium carbonate content is over 80%. Caliche can also be fired and used as a source of lime, which can then be used for soil stabilization. formation. When mixed with small amounts of either pozzolan or Portland cement, caliche can also be used as a building material that exceeds building code requirements for unfired masonry materials. For example, caliche was used to build some of the main buildings in the Yucatan Peninsula in Mexico, a dormitory in Ingram, Texas, and a demonstration building in Carrizo Springs, Texas for the United States Department of Energy were also built using caliche as part of studies by the Center for Maximum Potential Building Systems. In many areas, caliche is also used for road construction, either as a surfacing material or, more commonly, as base material. It is one of the most common road materials used in southern Africa. Caliche is widely used as a base material when it is locally available and cheap. However, it does not hold up to moisture, and is never used if a hard rock-based material, such as limestone, is available. Sugar refining. A nearly pure source of calcium carbonate is necessary to refine sugar. It must contain at least 95% calcium carbonate and have a low magnesium content. In addition, the material must meet certain physical requirements so it does not break down when burned. Although caliche does not generally meet all of the requirements for sugar refining, it is used in areas where another source of calcium carbonate, such as limestone, is not present. While caliche requires beneficiation to meet the requirements, its use can still be significantly cheaper than shipping in limestone. Chilean caliche. In the Atacama Desert in northern Chile, vast deposits of a mixture, also referred to as caliche, are composed of gypsum, sodium chloride, and other salts and sand, associated to silt. Silt, in turn, is a composite of sodium nitrate and potassium nitrate. Silt was an important source of export revenue for Chile until World War I, when Europe began to produce both nitrates industrially in large quantities. These deposits are the largest known natural source of nitrates in the world, containing up to 25% sodium nitrate and 3% potassium nitrate, as well as iodate minerals, sodium chloride, sodium sulfate, and sodium borate. The caliche beds are from 0.2 to 5 meters thick, and they are mined and refined to produce a variety of products, including sodium nitrate, potassium nitrate, sodium sulfate, iodine, and iodine derivatives. Caliche and gardening. Problems caused by caliche. Caliche beds can cause problems for agriculture. First, an impermeable caliche layer prevents water from draining properly, which can keep roots from getting enough oxygen. Salts can also build up in the soil due to the lack of drainage. Both of these situations are detrimental to plant growth. Second, the impermeable nature of caliche beds prevents plant roots from penetrating the bed, which limits the supply of nutrients, water, and space so they cannot develop normally. Third, caliche beds can also cause the surrounding soil to be basic. The basic soil, along with calcium carbonate from the caliche, can prevent plants from getting enough nutrients, especially iron. An iron deficiency makes the youngest leaves turn yellow. Soil saturation above the caliche bed can make the condition worse.